Hello everyone. In this lesson we're going to be focusing on cylinders and cones. And cylinders are similar to prisms because they have two bases, and cones are similar to pyramids because they have one base. However, with cylinders, the bases aren't polygons, they are circles. And we can see here that we have the height and the radius of our cylinder as the two main defining features of the cylinder. And a cone is similar to a pyramid because it has one base, except the base is a circle. And notice once again, we have the height and the radius as defining features, but just like a pyramid has a slant height, cones also have a slant height. And notice we get a right triangle. So once again, we'll be working with the Pythagorean theorem and Pythagorean triples. Let's take a look at the formulas for working with cylinders and cones. So as I said, a cylinder is similar to a prism. So here on the left we have the formulas for working with a prism for lateral area, total area, and volume. Let's take a look at how we could transform these formulas to make them work for a cylinder. Well, lateral area of a prism is perimeter times height. With a cylinder, the perimeter is actually the circumference of a circle. So we're going to replace this P with the formula for circumference, 2 pi r. So 2 pi r h will be the formula for the lateral area of a cylinder. What about total area? Well, once again, total area would be lateral area plus 2 base areas, but because the bases are circles, we can substitute in the formula for the area of a circle, which is pi r squared. So lateral area plus 2 circular base areas. And then for volume, once again, we're substituting in place of the base area, pi r squared, and then we have times the height. So basically, in each of these formulas, I just replaced the perimeter with circumference and the base area with the area of a circle, since the base is a circle. Let's do something similar for transforming the formulas for a pyramid to the formulas for a cone. Once again, I'm going to change out the perimeter for the perimeter of a circle, which is really the circumference of a circle. So we'd have 1/2 times 2 pi r times the slant height. And if you want to simplify this, notice the 1/2 and the 2 would cancel. So really our formula is just pi times radius times slant height. Total area would be lateral area once again, plus the area of the base, and since the base is a circle, I'll have pi r squared here for the base area. And for volume, once again, in place of the area of the base, I'm going to substitute the area of a circle, pi r squared. So we have 1/3 pi r squared times the height. So once again, I just substituted out what I know about a circle, the area of a circle for the area of the base, and for perimeter I replaced it with the circumference of a circle, 2 pi r. Let's take a look at how these formulas work with some examples. So here we have a cylinder, and its base area is pi r squared, and notice here I've got the diameter, so the radius is 5, so the area of the base would be 25 pi r squared, square centimeters for area. The lateral area, if you remember, is, well, let's go back and take a look at the formula. For a cylinder, the lateral area is 2 pi r times the height, because it's the perimeter of the base, which in this case is circumference because the base is a circle. So we'll have 2 pi r, so 2 pi times the radius, which is 5, times our height, and our height is 7. So this would be 70 pi centimeters squared for the lateral area. Total area is our lateral area, so 70 pi plus 2 of the base area, so that'd be 50 pi and that would be a total of 120 pi square centimeters. And last but not least, volume. Volume we know is pi r squared times the height, because it's the area of the base, times the height. So I have 25 pi for the area of the base, times our height of 7, and that would give us 175 pi centimeters cubed for volume. Let's take a look at an example involving a cone. So here I've got the diameter of the base is 24 meters. That means I know that the radius is 12 meters. And I need to actually also know the height of this cone to figure out its volume. So notice I've got 12 meters here and 13 meters here. That means the height would have to be 5 meters. 5, 12, 13, Pythagorean triple. And it looks like I did not do a great job drawing this to scale, because my 5 centimeters is actually longer than my 12 meters. Oop. Not centimeters, meters. My 5 meters is longer than my 12 meters. There we go. All right, let's take a look at this. Base area. Well, the area of the base is just the area of the circle. So I'd have pi times 12 squared, or 144 pi meters squared. And lateral area, if we go back and look at the formula for lateral area of a cone, it's pi times radius times slant height. So pi times the radius, which is 12, times our slant height of 13. And when we multiply that together, that gives us 156 pi meters squared for the lateral area. Total area is the lateral area plus the area of the base. So I need to add 144 pi and 156 pi. And this would give me 300 pi meters squared. And then volume is 1/3 base area. So 1/3 times 144 pi times the height of 5. And I know that 3 goes into 144 evenly, because the digits of 144 add to a multiple of 3. So let's see, 3 goes into 14 4 times, and then 24 8 times. So we have 48 pi times 5. Let's see, 48 times 10 would be 480, but then I would cut that in half since I'm only multiplying by 5. So half of 480 would be 240. So 240 pi meters cubed would be the volume of this cone. Let's take a look at one final example. Here it says that a cone has a radius of 6 and a height of 12, and it's filled to capacity with liquid. Find the minimum height of a cylinder with a radius of 4 that would hold the same amount of liquid. So first, I need to find the volume of my cone. So volume of a cone is 1/3 times the base area, which in this case would be pi times 6 squared, times the height. And let's see, 3 goes into 12 4 times, and then 36 times 4, this would give me 144 pi centimeters squared for the volume. And now we're going to work with a cylinder. So the formula for a cylinder is pi times the radius squared times the height. Let's see, we want it to hold the same amount of liquid. So the volume is still going to be 144 pi. And we're told that the radius is 4 centimeters, so I have 4 squared times the height. So I divide both sides by pi, and then I'll have 144 equals 16h, and dividing both sides by h, or not by h, by 16, gives me that h is 9 centimeters. So make sure that you have those formulas copied down. If you lose your notes and can't find your formulas, all the formulas that we've been working with in this chapter can be found on page 518 in the chapter summary. And we'll be working more with cylinders and cones tomorrow.